Okay, so for the next part in chapter 7, section 6, we're going to look at solving rational inequalities. So here, you need to do a few things. Here's the steps. Step 1, set your denominator equal to 0 and solve. This is going to be one of your possible solutions. So then on a number line, you put that number on what x cannot be on a number line. Okay? And then you go ahead and solve it like normal. Treat it as an equal sign, right? How do you get rid of division? Dividing by something, even though if it's really complicated, right? Don't you just multiply by that same thing and those will cancel out, right? You just got to multiply the other side by that, whatever that thing is, right? Okay. So then once you solve that answer, you put that number, x equals whatever on a number line, okay? And then you want to test the values. The last step is you just test the value. So usually you could plug in a number here, pick a number to the left of this, plug it in, see if it's a true statement, and then test a number in between and see if it's true, and then test a number on the outside and see if it's true. Now sometimes you can usually get away with just testing a number on the inside, because if it's true in here, that means it's true between these two values. Okay, it's true between these two values. If it's false, if you test a value in between your two numbers and it's false, that means it's usually true on the outside. Now sometimes it is true everywhere, it could be true everywhere, or sometimes it could be false everywhere there is no solution. But usually we can get away with testing numbers in between, and if it's true, then it's true in between. If it's false, then it's true on the outside. Okay, so here's an example. So here what I want to do on this problem, maybe, what I want to do on this problem is set my denominators equal to 0. So I can't set that equal to 0, and I can't set that equal to 0, just the one with an x. So I set that equal to 0, and I can see x does not equal -1. Okay, so then on a number line, I'm going to put -1 on a number line. Okay, and then I'm just going to solve this equation. Okay, to solve this one, just like the other one, we can do it a few different ways. We can combine those first, right? And then we can set up our portion, or I can find the LCD, which the LCD here is just 2 times 3 times x plus 1. So that'd be 6 times x plus 1, right? So then when we multiply everything this by it, right, the 2 is going to cancel with the 6, and we'll get 3 remaining. So we'll have 3 times x plus 1 times this x on top. And then when we multiply this LCD by this one right here, the x plus 1 is going to cancel, so we just get -5 times 6, which is just -30. And then when we multiply it by this one here, the 3 is going to cancel with the 6, so we get 2 left. So we get 2x plus 1 times an x minus 4. Okay, so then we just simplify here. So we get 3x distributed, so I'm going to take the 3 and distribute, and the x and distribute it. So that would just be 3x squared plus 3x minus 30 equals, here we're going to FOIL that out and then distribute the 2. So that'd be x squared, right, and x squared minus 3x minus 4, and then distribute this 2 to all three of those, and we get 2x squared minus 6x minus 8. And now we can set this equal to 0 and solve. So I set this equal to 0 and solve. I'm just going to subtract all those. So that would leave me with an x squared. That would leave me add 6x to both sides. That'd be a 9x. And then add 8. Add 8 would be -22. Okay, so then we can try to cab this. So since it's negative, we're going to subtract. Since a is 1, we don't have to divide by our a, right? So it's just x minus 11, or plus 11, times x minus 2, right? Because that would get me to -22, and subtract would get me to 9, equals 0. Don't have to divide by a because our a is 1. So solving, I'd get x is equal to -11, and x is equal to 2. So then on a number line, what I want to put down when I do this is I want to put what x cannot be. So on a number line, I want to put, when I set my denominators equal to 0 and I solve them, so I want to put -1 on a number line, maybe like here, and so that would be 0, 1, 2, and then -11 as well. So I'm going to put these also on a number line. So -2, -3, -4, -5, -6, -7, -8, 99, and whatever -11 is. It doesn't matter. It doesn't have to be perfect. Okay. So I'm going to put those in, and now I'm just going to test in between to see where my solutions are. Okay, so I'm going to test on an interval. This would be step 4, testing on an interval to see where it's at. Okay, so this can be a little bit tedious. Okay, so what I would want to do is I would normally test a number to the left of this, so say like -13. So I'd test -13. So I want to plug in -13 into this original equation. So it's x over 2 minus 5 over x plus 1 is greater than, this is what we're testing, so we're trying to figure out if that's true, x minus 4 over 3. So figuring out the math here, doing this problem, I get -78 over 12 plus 5 over 12, just getting a common denominator over 12, right, is greater than, we're going to see if that's true, -68 over 12. And again, I'm just combining -17 over 3, getting a common denominator of 12. Okay, combine these now, you get -73 over 12. Is that greater than -68 over 12? No, this is more negative, right? So that's not true. So -73 over 12 would be less than -68 over 12. So that's not true. Okay, so then we look at our number line here and say, okay, that's not true. So our answers will not be over there. Now let's test in between -11 and -1. How about -4? 2, 3, 4. How about -4? We'll see if -4 is true. Okay, so we plug in x equals -4, so we get -4 over 2 minus 5 over x, -4 plus 1, which reduces down to -2 plus 5/3. Okay, and we're going to see, is this greater than or equal to our x, -4 minus 4 all over 3? Is that equal to -8/3? Okay, so then we can combine these two, and so we get -1/3. So -1/3, is that greater than -8/3? Right, and since this negative is smaller than this negative, that would be true, right? So this is true, so we're true here, so that means our answers are in between -11 and -1. So now we can go ahead and test. So now we can go ahead and test and see about over here between -1 and -2. So now we're going to test in between here, so we can do 0. Okay, so x equals 0, so we can test that. So 0 over 2 is 0, minus 5 over 0 plus 1 is just -5, correct? -5. And is that greater than 0 minus 4 over 3, which is greater than -4/3? Is -5 greater than -4/3? Nope, because that's a bigger negative, right? So that is not true. So that doesn't work. So now looking at our number line, this is not true. So now we can test after that. So say, let's go ahead and test 3. So x equals 3. So we get 3 over 2 minus 5 over 3 plus 1. Is that greater than 3 minus 4 over 3? And so doing the math here, it reduces down to eventually -3/12 is greater than -4/12, just finding common denominators, right? And that is true because this is a smaller negative than this one. Okay, so that is true. So we're true there. So that means our answers would have to be true after this. Our answers are between -11 and then what is our symbol to begin? Just less than. So since it's just greater than sign, we do a parenthesis on 11. So 11 to -1. -1, it can't be -1, right? Because you can't plug a -1, so that's a parenthesis. And then we go from 2, and since we're just a greater than sign, it would be just a parenthesis on that too, and then to infinity. So there's where our answers are at, between those values of x. And if it was an or equal to, these would be brackets on these two where we got our answers to the problem. But whenever you say your denominator equals 0, it would always be a parenthesis. But because ours doesn't have an or equal to, these are actually parentheses here and a parenthesis there. And so this is where our answers or our solutions would be.